Hello, my name is Jason Woodring, and this is my project proposal for MEMS 5001 Optimization Methods in Engineering. The problem I will be optimizing is the control surface sizing for the Biom aircraft, which is a research aircraft shown on the right that flies using a bell-shaped lift distribution and a progress yaw control scheme to control itself in the yaw direction without any vertical surfaces or a rudder. It has two sets of ailerons called innerons and outerons, which are shown in pink and in red on the plot on the right. So the control surfaces will be optimized to produce the required amount of control authority while minimizing the amount of drag that they produce when they deflect. And one important thing to note about this problem is that due to how the aircraft controls itself, the sizing of the two surfaces is linked together. So the size of one will affect the size of the other. So some quick background on the problem. The bell-shaped lift distribution is shown above, and the downwash that this produces along with the downwash from the typical elliptical lift distribution is shown. The bell shape has a parabolic lift or downwash distribution, which results in progress yaw towards the wingtips and upwash in a region of induced thrust rather than drag. I'll approach solving this problem by splitting it into three subproblems. Firstly, I will calculate where the region of induced thrust actually ends using a panel method code rather than theoretical calculations, and this will produce constraints on the sizes of the outerons and the innerons. Then I will optimize the size of the outrun within those constraints to find where it produces the required amount of roll and yaw moments with the minimum amount of drag. Then once that size is set, I will optimize the inneron within those constraints and set it to produce an equal and opposite roll moment to the outeron. And I will optimize its position along the span and its length and chord fraction. Both of these will create multivariable problems with the cost functions based off of the drag from the panel method code.